Alright, hello, my name is Yash Anand, and here is my Linter project contributions for the red team. Um, the checks that I decided to do for my cursory style check, I'm doing poor names. The way I did that is I first check for camel case, then I check for length. I found that conventionally your variables should be of length between 2 and 20, and then I have a list that I found online of commonly used bad variable names. So we'll have a check for that as well, and we'll see that in action. For the principal violation check, I decided to do the dependency inversion principle, and we have an example of that as well. And then for the for the pattern detector check, I did the decorator pattern. And the way I did this check is sort of using the book as an outline for what to look for in a decorator pattern. The classic thing that you want to look for is if the class extends another class and has an instance of another class, of that same class rather. And that's how you know you're dealing with a decorator. And then if you are, then you want to make sure that you have that decorated method implemented. And that's what my check checks for, is those two things. So we can start by looking at the name checker here for the bad naming conventions. And the way I decided to test these was either on themselves or through example files. So starting with this one, it'll run and it'll show us that we have a few failed name checks. We have a convention failed. We have the variable var, should not be using that. This here breaks camel case. It starts with a capital letter, variable number, and this variable name is way too long. It's longer than 20 characters, so it fails the length check there. So what we can do is go here, comment out these three variables, and run that check again. Those variables thankfully weren't doing anything, and now it tells us that no bad variable names have been found. So that is the cursory check down there. Now we can go ahead and look at the dependency inversion principle. So we'll go ahead and run that, and it'll show us that it's violated the inversion principle on the class checker. And this is because we have two instances of variables that both extend checker, but we are we are declaring them rather with their implemented classes, not with their the class that they actually extend. So if we were to go ahead and change both of these to what they should be, which is just checker, we can go ahead and run that, and it says that the dependency inversion principle is not violated. Moving along, we have our decorator pattern check. And for the decorator pattern, we have some example files here. We have this abstract example file. We have a method inside of it that's public, and this is the method that we want to decorate. And here's our current file. All the code is commented, so currently it should fail the check. And the way that this check is going to work is first it's going to see if we have a decorator, and to do that, as previously mentioned, it needs to look at if you are extending a certain file and if you have an instance of that file. And there's your classic decorator pattern. And then to make sure that it's doing it correctly, it looks at if we have a method, which is going to be right down here. And so if we have no decorator detected, it should just tell us that outright. If we have a correctly decorated implementer, it'll tell us that. Or if we have a decorator but it's not correctly implemented, it'll tell us that it's missing the decorator method. So let's go ahead and run out our fully commented code in the file, and it says we have no decorator detected. So we can go ahead and comment all of this back in, and now it should tell us that we have our working decorator pattern, and there it is. Now, lastly, that is all of the pattern checks done. Now for my level 4 design, I decided to use a type predicated code checker. So if you're ever trying to check the type of a variable that you have in your code, this is not what you want to do. This is a principle we talked about in 220 a lot, but we didn't really talk about it in this class. And this is a lesson I learned pretty painfully in 220. losing a lot of points. So if I had something like this, maybe that wouldn't have happened. Um, Now, the way the type predicated code checker works is pretty simple. It runs through your code and it checks if you are trying to check the type of any variables, and if you are, then it tells you the line number that you do it on, as well as it gives you the line of code itself that where you're doing it. So if we go ahead and add that code in there and run it, it'll show us that we have some type predicated code on line 26, and it shows us that this is the code that is causing that check to fail. We can go ahead and remove that code, and we run it, and it says that there is no type predicated code detected.